What's up, guys? It's Bevel here. Today we're talking about SMAW electrodes. We're talking about the classification, what the numbers mean, how to set your machine up to run these things. So first off, when we start on this table up here, there's three classifications of sticker electrodes. You have filler rods, fast fill rods, and fast freeze rods. Now today we're going to talk about carbon steel. All these electrodes we're talking about are carbon steel because that's what we're going to teach you here at Drake. Now you can weld stainless and aluminum with SMAW electrodes. That's not really something we teach here. Aluminum's hardly ever let you do that in the industry. Now if you focus on the pipe industry, it's possible we will touch on some stainless stick welding if you go to pipe field. But today we're going to learn about carbon steel. So the first one we're going to talk about is the filler rods. Pretty common. These rods would be like your 70-18s, 60-13s, 80-18s, anything in those categories. They have a smooth finish to them, so they're used like surface welds. So a surface weld is something like a cap or a filler pass. And now this is kind of a description of that. As we can see, we have a parent material. This is what we can see on top with a naked eye. This is how deep it's penetrating into that parent material. So surface weld's got a pretty good smooth surface on top, but it is penetrating that material, not real deep. Now, kind of opposite of that is we have a fast freeze rod. You can see it kind of humps up there on top on the surface, doesn't flow real smooth, but a really deep penetrating rod. So we have the fill rods, or surface weld rods. We would use those in situations where we're capping a part or putting fillers into a part. Now, very similar to the filler rods, we have the fast fills. Sometimes the industry would call these jet rods. Typically, we can see like the 70-14s and the 70-24s. So a fast fill rod does the same exact thing as a filler rod, but it has a high deposition rate. It means we put a lot of material into a joint quicker than something like a filler rod. Typically, you might want to put a note of this, these rods are normally used in the flat and horizontal position only. Now it is possible that we can do those 74 kick and all positions, but typically they're all in the flat and horizontal positions. So why would we want that? Well, stick was one of the, or SMAW was one of the first welding processes created. So what they did is, as before we had big flux core, so if we were production making a lot of parts, we could use a fast fill rod and have that higher deposition rate, put more metal into a joint quicker, versus we're just building a select few rods. So that's kind of the reason behind it. Not a super popular thing you do a lot. Iron workers use them a pretty good bit. So that's our fast fills. Now we have our fast freeze. So the fast freeze rods would be our 60-10, 60-11s, rods in that category. So basically what happens is called a fast freeze because as we weld, we put that rod in there. As we're making our weld, we actually create the puddle, and we whip our rod out of that puddle and let this puddle freeze while still keeping the arc going. Then we set another puddle down in front of it, let it freeze. Set another puddle down in front of it, let it freeze. So it's a fast freeze rod. A lot of times we use a whipping notion with it. Now, a rod like that is a deep penetrating rod, like we talked about, but it's not going to put a real smooth surface on it. So these are really good for running open roots, or if you want anything with a low heat affected zone. So what that means is since we're not keeping a continuous bead like we do with fast fill or filler rods, we're setting the bead, let it freeze, setting the bead, let it freeze. We're not putting as much heat into that part. So that's why it's ideal for something an open root where we don't have a continuous weld joint or anything like that. Thinner material, something we don't want to put a lot of distortion or warp to. So that's the three different classifications of rods. Why do we need to know that though? So we need to know how they're set up so we know how to set our machines. So this is what we call it on the machines, it's called soft, or it's called crisp and stiff. Crisp is Lincoln, stiff is Miller's, but it's the same thing. So if you have a fast fill rod or a fill rod, they're designed to be welded on soft, because that's what they're doing. We're putting a good soft finish on top. We're getting some penetration, but not a whole lot. Well, crisp is designed, we're not really worried about what the top looks like, we want that deep penetration. So you need to make sure you set the machines right. So just to reiterate, we want fast fills and fillers on soft, we want fast freezes on crisp or stiff, depending on what brand machine you have. So, we talk about all these different numbers and stuff. What do these numbers mean? So 7018, most common stick electrode in the world. Talk about what those numbers mean. So our first set of numbers here is 70. Those stand for tensile strength. Tensile strength is how much force it takes to pull something apart, what it takes to rip that apart. And so you want to make a note of this is the minimum tensile strength of a weld. And we always multiply this number by 10,000. So the tensile strength of a 7018 is 70,000 psi, pounds per square inch. So it takes a minimum of 70,000 psi to pull this weld apart, if we've done it correctly. So the first set of numbers is tensile strength. The next number we have there stands for position. Now by now you should know the different fillet weld positions and groove weld positions. And so this can kind of be confusing because one we think of a lot as flat. Because if we have 1F fillet weld, that's flat. 1G pipe, that's in flat rotating position. But this stands for, put a note of this, 1 means all positions. So it can weld in all those different fillet weld and groove weld positions. Now, we talked about fast fills earlier, and I pointed out that the 7024s are flat horizontal only. So you might want to put you a note that 2 stands for flat and horizontal only. The chemical makeup of that rod has too much iron powder or whatever it is to it that won't let it weld vertically or overhead. It'll roll out and not stick to our weld joint. So 1 stands for position, so lets us know what positions we can weld that rod with. The last number, number 8 there, stands for composition. Composition tells us what this rod is made of. The main thing we really want to know about composition is, and what it's made of, it tells us what polarity to set our machine to. And I'll go ahead and tell you the 7018, that 8 stands for DCEP, direct current electrode positive. So, we got tensile strength, position, and polarity, or composition, which will tell us polarity. Now, we talked about machine setup before, you should know how to change your polarity. So now when we go to weld with the rod, we know what the numbers mean, how to set our machine up versus what these numbers are. And so we're going to jump into the actual size of the rods now. Now this is my attempt at drawing a SMAW electrode. And now on this electrode, there's kind of 2 main parts to it. We have the metal core to it. The core is what we determine the size of this rod. So whatever diameter this core is the size of the rod. Now, we would say the type of rod would be 7018. And the size could be, for example, this one's a 332-inch diameter. Now they have flux coatings on them. So the flux coating is actually made to produce the slag that we'll have to chip off of our weld when it cools. The metal cores would actually create the weld metal in there that's going to hold those 2 pieces of base metal together. And the flux coating, that's going to look different on different type of rods. We'll get into that in a minute. But it can be different sizes as well. And that's what actually produces the slag that protects the weld until it gets cooled off. Because SMAW does not use a shielding gas to protect its weld. So the core is the diameter of the electrode, and the flux is going to be what actually protects it. So let's look at some different rods here that have the same size diameter, the same size core, but they have different fluxes to them. So all 3 of these rods are 1/8 diameter cores, but they have different fluxes. So here we have a 7024. You can see it has this brown flux to it. And it's a lot bigger than the rod beside it. Again, all these are 1/8 diameter rods, so the same size rods. This one in the middle, we have a 6010. 6010 doesn't have a big flux to it. It doesn't produce a lot of slag. Then we have a 7018. Again, it's a 1/8 7018, but it's got a lot more flux than a 6010, but not near as much as a 7024. So it's going to produce a pretty good bit of slag, but not near as much as a 7024 would. So it's possible that you have rods are going to look a little different, especially different manufacturers. You know, if this is a Lincoln Electric rod and this is a Hobart rod, they might look a little bit different. but they can all be the same size and have different fluxes. And that's pretty much it on the different classifications and all we need to know about the different electrodes in SMAW. Appreciate it, guys.